Hi, this is Mr. Ward. I'm going to do a video on factoring quadratics where the lead coefficient isn't 1, because these are a little more complicated to deal with. And in a little while, we're going to get some better tools for this. But for right now, I'm just focusing on ones. Those tools are also used for situations where you can't factor into neat and tidy numbers. There's going to be square roots involved and stuff like that. But for right now, we're going to deal with some that square roots are not involved, and we could use some of our factoring tools. So when you look at this polynomial, 3k squared minus 10k plus 7, we know that we could break this up like this. We're going to be able to break it up into a couple of binomials, okay? And the trick is figuring out what's going to go in front of this k. So we're going to have a k here. We have to have a k here. We're going to have a k here because we have to get a k squared. Now, since 3 is a prime number, it's a pretty good bet that just one of these is going to be a 3. Okay, so 3k times k will get you a 3k squared. And then since 7 is a prime number, one of these will be a 7 or perhaps a negative 7 since this is negative. So it can sometimes be tricky to work out. So I'm going to go ahead and work it out here one way, and I'm going to work it out a second way. So you can kind of eyeball it and work it out. So 7 times 3 would get you 21. So if I put a 7 here and a 1 here, that's a 7 times 1. That gets me a 7. But then I've got an outside product of 21k and an inside product of 1k. So that seems a bit iffy. So we're going to switch that up, because 21k plus 1k is going to be 28k. We need to switch that up. We need to actually put the 7 here and the 1 here. Okay, and now 7k and 3k, 3k times 1 will get us 3k. 7 times k will get us 7k. That adds up to 10k, but in fact, we have a negative 10k, so we're going to put a negative here and a negative here. All right, so I factored it, but I want to show you another way to approach it. Another way to approach it is to use the old X structure. And there's several other methods you'll find out on the internet, and any and all of them are useful. I would recommend making sure you know this one, but I have no attachment to this being your only go-to for figuring it out. So this inside, in this middle term, the negative 10k came from the sum of negative 7k and 3k and negative 1. That's where it came from. So that's a negative 7k. So what that means, what kind of tells us, is that the 3 and the 7 and any number of 1s are involved in coming up with that middle term. Now, the 3 and the 7 are involved in getting the 3k squared and the 7 as well. So I'm just going to go ahead and say 3 times 7 here, which is, of course, 21. And so I'm going to need 2 factors of 21 that add up to the middle coefficient. Middle coefficient is negative 10. And we've worked out that those would end up being not 3 and 7, because those add up to positive 10, but negative 3 and negative 7. Now, once we know that, we can actually take this and we could break it up into a 4-term polynomial. We could say 3k. Okay, let's see if I can get the mouse. It's cold in this room, so the mouse pad is not recognizing my finger. Okay, so 3k squared. Okay, and we're going to break the negative 10k into negative 3k and negative 7k. So minus 3k, and then minus 7k, and then plus 7. Now I'm going to go ahead and group this here and here. And since I kept the negative inside, there's a plus here. And so what I need to do is I need to factor out the greatest common factor of these two terms, which is going to be 3k. And then inside, I'm going to be left with just k minus 1. Okay, and maybe that looks familiar to you because there's a k minus 1 up here. Here, I'm going to factor out not a 7. I'm going to actually factor out a negative 7, so minus 7. And then I'll be left with k. And if I factor negative 7 out of 7, I get minus 1. And now I have k minus 1, which is this, and I have 3k minus 7, which is this. And I would factor it like that. K minus 1, since they both share k minus 1 as a factor, times the combination of 3k and negative 7, 3k minus 7. And that will factor that. All right, let me pause so I can erase things. Now let's take a look at 5x squared minus 36x minus 81. That's going to be a little trickier because 81 is not a prime number. I mean, 5 is, so I know probably I'll be putting my 5 in front, 5x in front of just one of the two factors. But I'm going to go ahead and use the old x. And what I'm going to do is I'm going to say 5 times negative 81. Okay, and then I need, and then whatever that equals, needs to add up to negative 36. Okay, so plus 36. All right, so let's figure out what is 5 times 81. Well, 5 times 80 is going to be 400. So 5 times negative 81 will be negative 405. But I'm going to let you know, I agree with you. If negative 405 looks like a particularly annoying number to try to find two factors that add up to negative 36. Now, first of all, since it's negative, one of the factors has got to be negative and the other one has to be positive, right? So that's got to be aggravating. So we can't just add things. We need two numbers that are 36 apart. Okay, here's what I tend to do with this sort of thing. Since 81 can be broken up into factors, it is useful to break it up into its factors. So I'm going to have a 5. So these are all the factors I'm going to be playing with. 5 times 3 times 3 times 3 times 3. And then there's a negative 1 floating around in here somewhere. Okay, so now I can start thinking about, okay, how could I get something that is 36 apart? Well, let's look at things. 5 times 3 is 15. 3 times 3 times 3 is 27. That's too close. 15 and 27 are too close. So I need one of my numbers to be bigger. I don't want it to be 81. So 3 times 3 times 3 times 3 is out. So I'm going to think about another way to group it. 5 times 3 times 3 is 45. Okay, and 3 times 3 is 9. 45 and 9 are definitely 36 apart. So actually that's going to work. So if I break this down into a 45 and a 9, then I've got to figure out which one's getting the negative 1. 45 times 9 is going to be 405 times negative 1 will make it negative. And 45 minus 9 would get me 36. So good, those are the right distance. However, got to figure out where the negative 1's going. The negative 1 has to go to the number that's bigger. So that's going to be the 45. So 45 gets to be negative, and that gets to be a 9. Now I'm going to bring in my old friend Desmos here, and we're going to use that because I can type a lot faster here. So what I'm going to now do is I'm going to take this, 5x squared minus 3x, the 36x minus 81, so 5x squared minus 36x minus 81, and I'm going to split 36 into negative 45x plus 9x. And then I'm going to group them. I'm going to group this. I'm going to group this. I will stretch out that cell so you can see what the heck is going on. Will let me. I think I need to stretch it this way then. Okay, maybe I need to also, yeah, that'll work. That should do. Okay, so now what I need to do is I need to pull out a common factor here and a common factor here. And I'm hoping that I'll end up with the same factor inside the parentheses. So if I pull out a 5 from here, that'll leave me with just x squared minus 9x. But I can also pull out an x. So I'm going to pull out a 5x. So 5x will leave me with x minus 9. And then over here, I can pull out a 9. So 9 will pull out, I can pull that out, and that'll leave me with an x minus 9 as well, which tells me that my factors are x minus 9 times 5x plus 9. And there we go. And you can see on the graph over here, it ended up being the same thing each time. I turn the original one on way back here. That's the red one. That's the factored version. And I'll make that bigger so you can see the whole thing. It's the same equation. Okay. Let me go back over here. And so this approach of breaking it down into its factors is definitely a tool that I would recommend using. I will be glad to make this video has gone long enough. I'll be glad to make some additional ones as people need, and I'll go over things in class for folks as you need. I hope that this was helpful. Oh, I do want to recommend pretty strongly going to this site where if you go, this is linked, of course, in the big polynomials document. If you go to the big polynomials document and you go to this section, you'll see the Mesa Community College notes, and then Mesa Community College practice and solutions. There's also Khan Academy, and there's a chapter 8 thing, chapter 9-8 from textbook. Let's go and take a look at the Mesa Community College notes. And here we are. It's got examples worked out, and it shows examples where we're taking the product of our first and last coefficients. We're figuring out what the factors are of it, and we see which factors would work to add up to our middle coefficient, which happens to be 1 here. So 6 negative 2 got us negative 12. We're looking for two factors of negative 12 that will add up to 1. Negative 3 and 4 will do it. And negative 3 times 4 will get us negative 12. And then we break up that just 1x into a negative 3x and a 4x. That's the same as plus x. And then we factor by grouping. And there are further examples that are more ornery. This is definitely a more ornery one. In this case, this is the approach that's recommended here. You can definitely do that, but I would probably end up breaking 12 into 2 times 2 times 3 and 15 into 3 times 5. And I would mix and match until I had 2 sets of factors that gave me the 2 products that would get me to negative 29. There's obviously going to be negative factors involved in this one. So this ultimately worked out that 9 and 20 add up to 29. So negative 9 and negative 20 add up to negative 29 and so forth. So, but as you can see, works the steps pretty thoroughly in here. And then there are further practice problems from the Mesa Community College site right here. And you're given these problems on the left. This one, of course, won't require factoring by grouping, but you could. And you can hover here over the answer, so you can see the answer. And if you're not sure how the heck that happened, and notice here there's some factoring out of greatest common factor. If you're not sure how the heck they did it, you can go over here to the complete solution, and it opens up the steps for how it was done. So it's a pretty good site. The other site you want to check out You'll probably want to check out the Factoring by Grouping textbook PDF. And then you can check out Khan Academy notes. Okay, so I hope this was helpful, and be glad to talk more about this in class.